I'm in the Gatesville, Perrinville, Dollarville, Ontonagon, Hermansville, Allenville, Randville, Eagle Harbor, Watersmeet, Matchwood, Marquette, Berglund, Germfest. Hi, this is Jim Isleib with MSU Extension, and this is What's Up at Uprec on May 13th, 2021. Today we'll continue with part 2 of the episode on water on the farm here at Uprec. Protecting water quality is a key part of the environmental program here at Uprec. The farm is environmentally assured under the Michigan Agriculture Environmental Assurance Program, and part of that is to follow standards that protect surface and groundwater quality. We'll visit today with Rob Wiener, MSU Extension environmental educator based in Alger County. Rob will be doing some water quality testing on the Slapneck Creek, which you see behind me. You can see the steep slope of these pastures on either side of the Slapneck Creek, coming down from the North Farm buildings down to the creek. There's a fence on both sides of the creek to exclude livestock so that they don't walk in the creek bed stirring up sediment, so that they don't leave any waste, any manure or urine in the water. And here on the south side of the Slapneck, the pasture slopes up quite abruptly up toward the village of Chatham. Slapneck Creek runs right through the farm property, and as such it is a vulnerable stream to environmental contamination. However, the staff here at Uprec does a great job of protecting the creek. We'll also hear from Erin Satchell after Rob is done, talking about the livestock manure composting site. So let's get busy and hear from Rob and Erin.
One of the first tests we'll do is to find out how much oxygen is in this water. Now, oxygen, we breathe in the atmosphere, but oxygen can also be dissolved in water, and it is dissolved in water, and we can do a test to figure that out. The first thing we'll need to do is to take the temperature, and we've done that. So we have the temperature. Now we need to take a sample very carefully of this water. To, as carefully as I can, add 2 of the test tablets. I want to try not to introduce any more oxygen into this water than is already here. Carefully cap it. And now what I'm going to do is to simply mix this up carefully by inverting the bottle. And I need to do this for several minutes until those caplets dissolve. We've gotten these tablets to dissolve, and then we had to let it sit for 5 minutes in order for the full color change to take effect. Now the last part of this test is that we're going to compare the color change to a chart that's provided with the test kit. So with the dissolved oxygen, you can see that there's different categories. This makes some big jumps from 0 to 4 to 8 parts per million. And so you might have to estimate somewhere between these. In our case here, it looks like it's pretty close to 8, maybe between a 7 or an 8. So once we have the result of this, we have the temperature. Now we can put that all together and find out what the dissolved oxygen is. The next test we'll do is to test the nitrates that are in this water. Now to do this test, we're going to fill up this tube to the 5 milliliter mark, which I've done. And we're going to add 1 of the tablets. Put the cap on. Now this one, it's really important while that tablet is dissolving that it doesn't get any light. So this has a special sleeve that's not going to allow any light to go in. And now I'm going to simply, just like I did with the dissolved oxygen, I'm going to invert this until that dissolves, and this will take a couple minutes. Okay, we've let the time pass. Now the moment of truth, we're going to take it out of this sleeve and look for a color change. We can see that there's just a very, very slight bit of orange The smallest category is 5 parts per million. So that tells us that this water sample has less than 5 parts per million of nitrates. So this is a very good sample. The next test we'll do is to find out the level of phosphates in this water. So just like the last test we've done, is we're going to fill up a test tube to a certain level, and in this case it's the 10 milliliter mark. Now we're going to put in the right test capsule and carefully put the cap on. And now, as with all the other tests, we're just going to have to spend a few minutes inverting this until that caplet dissolves. Okay, we've let the test caplet dissolve, and we had to let this then just sit for a while for any color change. So now the last step, just like with the others, is we're going to compare it. So again, we're doing phosphates, and we're going to compare the color to one of these, and I'm seeing just a little hint of blue, maybe close to 1 or less than 1 part per million. So again, we're getting pretty low phosphate levels, which also is a very good sign. Another test we can do is to measure the pH, which is a measure of the acidity in the water. And to do this, we're going to take a water sample up to the 10 milliliter mark and use the correct tablet for this. And just as we've been doing then, we're going to carefully invert this until that dissolves. Okay, we've gotten the tablet to dissolve and we've got a color change. Now what we do is we compare it to the colors on this pH chart, and we can see that this sample is really close to 7, which is exactly neutral on the pH scale.
Acceptable levels of dissolved oxygen, nitrates, and phosphates, and a near neutral water pH in Slapneck Creek indicate that farm activities at Uprec are not creating problems in these areas. The Michigan Agricultural Environmental Assurance Program is a partnership of organizations including the Michigan Department of Agriculture and Rural Development, Michigan Farm Bureau, Michigan State University Extension, and others, who provide an opportunity for farmers to do a voluntary assessment of their farms with a mind towards environmental safety. Upon successful completion of the program, these farms receive an attractive plaque to post out on the road so all passers-by can see that the farm takes environmental issues seriously. Water protection is one of the key environmental concerns in modern agriculture. The farm here at Uprec is environmentally verified under this program. There have been some changes made to satisfy the requirements, including the relocation of the livestock manure composting system. The manure from this composting system, much of it is certified organic and is used at the North Farm for vegetable production. The Michigan Agricultural Environmental Assurance Program has local technicians and verifiers to help with this process. Our verifier from the Michigan Department of Agriculture and Rural Development for the Upper Peninsula is Erin Satchell. And Erin was involved with the relocation of the livestock manure composting site.
Hi, my name is Erin Satchell, and I work with the Michigan Agriculture Environmental Assurance Program. The old composting area was on a location where sand and gravel has been removed in the past, and although that spot was a good choice for vehicle traffic, a number of other factors made that location less desirable as a composting area. The high permeability of that soil and the close proximity of groundwater to the soil surface meant that any nutrients that were lost from the composted materials could quickly get to groundwater. The level of the groundwater in relation to the soil surface can easily be seen where a slightly deeper area in the borrow pit forms a pond. The water level of that pond is an indication of the high groundwater level below the rest of the soil surface. Another result of soil and gravel removal at this site was that there was not much topsoil covering left, and the vegetation was also relatively sparse. So deep topsoil with lots of sod-forming vegetation helps in recapturing nutrients that might otherwise be lost in the composting process. That loss of nutrients, nutrients such as nitrogen, phosphorus, when those leave the farming system and are lost to groundwater or surface water, it's not only a financial loss to the farm, but It also can degrade the water quality for other uses, and it leads to negative environmental outcomes such as overgrowth of algae in the water and lowered oxygen levels. So avoiding those nutrient losses is a major concern when thinking about a composting site. The new composting site addresses those issues that were found at the old site. The new site is further away from surface water, and it's also at a higher elevation with more separation from the groundwater levels. The soil is less permeable, and it has a full vegetative cover with some good topsoil. Any surface runoff from that composting area also passes through a grass filtration area downstream, where nutrients that might be washed away from the composting site can be filtered out and taken back up into vegetation. The positions of the rows of composted material are moved as the rows themselves are turned through the composting process, and this allows new grass to regrow in those places where the compost has previously been piled. That further helps with capturing and recycling nutrients back into vegetation from directly below the compost piles, where it may have soaked into the ground and might otherwise have been lost over time.
That's what's up at Uprec. Hope to see you again next time.
Back at the place where the pace doesn't race, that's the old UP.